Hello. So today we're going to be looking at an overview of ratios and proportions. I almost said rationals there. I wonder why. Oh, well, we talked about rationals before. An overview of rational numbers. Rational numbers are numbers that can be written as a fraction. Another term for that would be numbers that can be written as a ratio between two whole numbers. So a ratio is just a comparison of one solution to another. They generally are going to be opposites of each other or odds to one another. But you could just write them as just being a fraction. For example, when I went to school at Georgia Tech, there was a popular song called Ratio. And it was based off the fact that at Georgia Tech, there were more guys than girls. And the ratio was actually about 5 to 1, boys to girls. Notice how I said boys to girls, 5 to 1, because the 5 goes with the number of boys in class versus how many girls are in the class. And so in the song, it was like the odds are good. For the girls, they would say the odds are good, but the goods are odd. It was a techie, nerdy joke kind of thing. Um, but anyway, it's a very cool and funny thing to help kind of visualize what a ratio is. It's a way for you to compare two things together. So, well, we've done that in similarity with fractions. And actually, ratios can always be written as fractions and generally are in order for to help you solve problems with them. For example, if I had the ratio being 5 to 1 in a classroom, let's say that there were 30 people in the class. So if the ratio is 5 to 1, I could write it this way. Well, what would the total be if this was just the class? There would be 5 boys and 1 girl, so it would be 6 people, right? Right. So if I wanted to know how many boys are in the class, that would be 5 out of 6 boys. 5 out of 6 are boys. Well, how many girls are in the class then? It will be, of course, yes, 1 out of 6 will be girls. Okay. So if I wanted to solve a problem with that, say, like I said earlier, there are 30 people in a class. If it follows this ratio, then that means 5/6 of the 30 would have to be boys. 1/6 of the 30 would have to be girls. 5/6 of 30. For every 6, there are going to be 5. So that would be, well, let's find out. Now I'll actually change that up here. So we get 5/6 of 30 would be times 30. So we will get 150 over 6, or we could just get 25. Well, if there are 25 boys, how many girls would that be? That's right, there would be 5 girls. We can just subtract that from the 30 that we started with. Or we can do 1/6 of 30, which would just be 30 divided by 6, which would give you 5. So either way, you can see how you can use the ratio to solve problems like that. Um, Many of you'll be looking at aspect ratios, or you may look at ratio of how much air goes into the compressor versus fluid, or there are all kinds of things you can look at and use the ratio in order to solve problems by changing it to a fraction. Notice how we added these two numbers to get what the denominator was here in this fraction. But before we wrote this ratio as 5 over 1 because it is 5 over 1 because we're comparing the 5 to every 1. 5 boys to every 1 girl. So those are different ways to represent a ratio, and that is an example on how to use one in the problem. Proportions are very interesting because you take these ratios and you take fractions and you use them to understand what a result may be. For example, if I said, hey, there are 7 girls in this class, how many boys are in the class? When you say, well, it's 5 to 1 boys to girls, or 1 to 5 girls to boys. So if there are 7 girls in the class, 7 times 5 would give me 35. So there'd be 35 boys in the class. And guess what? You would be correct. That is a proportion. It's actually a direct proportion. Direct proportion means that as one of these values goes up, the other one would have to go up as well. Well, if there are direct proportions for one going up, the other has to go up, then there must be something going opposite of that. As one goes down, the other goes up, or as one goes up, the other goes down. Because why would you call one direct? Right? Well, one's direct, the other's going to be indirect. We also have another name for that, inverse. And so those are different ways of having proportions. And it's very simple. As one goes up, the other goes up. Or as one goes down, the other goes down. Those are all direct because they're going in the same direction. Okay. Indirect or inverse. As one goes up, the other goes inverse. As one goes down to start, the other goes up. They're going inverse of each other, indirectly, opposite directions. Okay, so those are our proportions. We'll talk more in detail about those. So we have ratios and proportions. Ratios are just ways to compare two things. Generally, one's opposite of the other, or one's a possible outcome, the other is the other outcome. Proportions is a relationship between two things. We can see it as one increases how the other increases by the same factor. As one decreases, the other decreases by the same factor. That's direct. As one increases, the other decreases by a factor. As one decreases, the other increases by a factor. That is indirect or inverse. All right. I will see you soon.